Hey everybody, this is Larry. This is March 22nd. Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem and so forth. Wow, spell checker. So I work on these lives, so it's a little bit slow. Just feel free to fast forward. Okay, given a release list, we want to implement a spell checker to convert a query word to a correct word. Okay, what does that mean? What is yellow? Okay, goes to yellow. Okay. Capitalization. Okay, that's a little bit messy, but wow, errors replace. Say what? Yellow. Okay. That's a okay. I mean, this is a very wordy part. I'm sorry, I'm a little bit slow. It's just a lot of things to read, but n is equal to 5,000. So 5,000 squared times 7 is a little bit slow, at least in Python. Maybe in Java is fast enough because I've seen for some reason everything is fast enough in Java, but okay, if exact in the word list, okay, we match a word up to a capitalization. You for such match. What is for such match? Oh, in the word list. That's annoying. Match a word up to vowel errors. You should return the first such match in the word list. Okay. Okay. I think for these kind of problems, what I like to do is just look up the inverse or pre-cache the inverse thing that you're calculating, so that you could do all of one lookups and do everything in the pre-calculation, because the pre-calculation is usually not that expensive, and especially in case insensitivity. You just you can normalize the word by changing it to lowercase or something like that, and then just returning the first entry of that lowercase. And you always so the thing is that because you always return the first such match, it's first come first serve, so that's pretty much it, right? Like, what I mean by that is that you don't have to keep a list or anything. It's just always the same lookup. And then with the vowels, that one is the one that's a little bit tricky because there are 5 vowels. So yeah, so you might have to pre-calculate all of those. The other thing to notice is that the word list is 7, so that now 5 to the 7. What's 5 to the 7? Let's see. Let me put in my calculator. 5 to 7 is 78. 78,000. So 78,000. Oh wait, is it 5? What did I say? No, 5 to 7 is right? Yeah, because you have 7 characters, one for each 5. But that said, we can pre-calculate. Actually, no. I mean, what I was going to do is pre-calculate. Actually, it is something that I haven't done that much, but you can actually normalize it in a different way, which is that you can map all the vowels. You don't have to do all the 5 to the 7. You can map all the vowels to like an underscore, or in this case maybe even an A, because an A would be fast enough. Yeah, so I think that's mostly it. So it has to be in this order. Okay, so we have to do 2 set of things, I believe, because you want to check all the capitalization first before you check vowels, even if there's a type, like if there's a typewriter where 2 things match to the same thing, you want to match the capitalization first. So yeah, and then otherwise you return string. Okay, so I think we got the rules here. Let's figure it out. So let's just say I have 2 things to normalize. So let's just say I have a normalization lookup. This is a way long variable name, would not recommend it. So put in a hash table, and then we have the other wow normalization lookup. Yeah, and then it becomes for each word list, for word in word list, there's two kind of normalization, so we'll write them down. Normalize capitalization. So we have a word, and what is the normalized capitalization, right? It just return word to lowercase. Because then you could figure it out, and then here we would write if let's just say C word is equal to a shorter cap name. Okay, fine. Normalize capitalization word, maybe. I don't know. I feel like my name is very long today, but capitalization of word, and then if this thing, which I'm gonna copy and paste. Usually I don't, but this is really long. If this is not in this, then we set this up, right? And then we do the same for the vowels. And what the vowels, let's replace all the vowels with underscore and also lowercase them because it's case insensitive. Yeah. Well, actually, so one more thing that we have to do is actually, I missed a little bit, which is that if it matches the word exactly with the case sensitive, then we should just return the same word. So one thing that we have to do is just, word set, say. So we have a set, yeah. So that's just the set of a word, and actually we can even just do this because I'm a little bit lazy. We could technically put it here as adding it, but it's fine. It's the same idea, right? Yeah. So yeah, and then the other one is normalize vowels, say vowels. And then now this one we can read. We can use a regular expression here, I think. I forget how to do it. I don't use regular expression enough to do it. I think it's just dot sub, something like that, maybe. Yeah. So, and technically, you should actually compile your regular expressions, and then we use that compilation for purposes. But for now, I'm gonna be a little lazy, and if I get in trouble with respect to whatever, then that's fine. But yeah, so basically what we want to do is we want to use the sub. We want to convert every case insensitive. I would say so. A-E-I-O-U. Something like this. How did I write it? Case insensitive. I know how to do it in other languages, but I actually don't know how to do it in Python. Oh, read that, ignore case. Okay, fine. Huh. Didn't know that one actually. Because in other languages, like you just had a flag for it. But yeah, but now we just let's replace it with an underscore, say. And we want to replace word and read that. What's it called? Where did I have my wing? Oh, read that, ignore case. Where did my window go? Okay. Something like that, right? And then we have to return it, obviously. But then now we go normalize while word is equal to normalize while word. And then we do the same thing of if this word is not in this lookup. And you can actually, the cool thing about a lot of these things is that you can actually dry this a lot using lookup tables on these things and like function pointers and function functors and function pointers or other techniques or meta programming stuff to do it. So these are things that I would think about. Anyway, what am I doing for each query? Okay, fine. So results, let's set it to an array for query in queries, maybe for word in query. Okay, if word is in word set, results start append word. That means, we're going down the line of these things. And then else, if word is in the capitalization normalization workup, results start append this thing. Maybe there's a better way of writing this. But otherwise, if word is in this vowel normalization lookup. Oh, also I think I messed up here. Hang on. Because I think this is also in case insensitive. So actually we don't even need this then. We can just do to lower to get the key. Yeah. Also I messed up. This is not quite right. But let me finish this. And then else results dot append empty string. So what isn't right is that we're not looking for the word. We're looking for the normalization of this word. So we have to add calling this to get the first entry. And that should be pretty much it, other than like minor typos or something like that. This should be the right idea, hopefully, and then we'll see. Ooh. Oh, it's not too low, it's lower. Maybe I'm thinking of another language. So many languages in my mind sometimes. Are these right? I click on show div, it looks okay. Is there another test case? Nope. I'm too lazy to come up with one, so assuming this looks relatively okay, let's give it a submit. Yikes. Okay, cool. Yeah, so what is the complexity of this? I mean, it's accepted. So yeah, so for each word we do, well, yeah, we definitely, well, for each word we only store it at most 3 times, one in word set, one in capitalization, so one in vowel normalization. So this is gonna be a linear space, right? In terms of time, okay, what does this look like, right? Well, this is going to be linear in the size of the word. This is also going to be linear in the size of the word, roughly speaking. You can say that, you could replace this with a for loop if you worry about the complexity of a regular expression. But yeah, so let's pretend that these two are both linear in terms of the character, and therefore, if you look at this, then we look at each character, constant number of times, because, that's just how it goes. And also, for each query, I think we can also save some computational by saving this variable. I think actually, now that I think about it, in Python, there's the walrus operator, right? I need to start using the walrus operator because I'm not that familiar with it, but I think this is one use case of that, maybe, if I write in a better way, so that you don't call the same function twice. But anyway, but that is just, minor details. Well, it's still, it's 2x, it's still hidden in the big O notation. But here, you can see that for each character in each word, it gets looked at a constant number of times. So this is going to be also linear in the size of the input. So O of n in the size of the input. In terms of words or words times length or whatever you like, but both are linear. So this is all going to be linear, and that's all I have for today, I think. Let me know what you think. So what are the lessons here? I think it's just try to think about a way to normalize, and what it means is that try to figure out a function that no matter what happens will give you that one function, or and then you can use this lookup to kind of reverse it back out of that. But yeah, let me know what you think. Have a good, it's Monday here, or it's going to be Monday here, or whatever. Hope y'all have a good week, and I'm tired. So yeah, I'll see you later, and have a good night, have a good day, have a good week. Yeah, take care, and to good mental health. Bye-bye.